Many pilots had their doubts from the beginning. Airbus industry has introduced new ways into the design, meaning the development and construction of the user surfaces, above all the cockpit and its systems. A flight engineer has become unnecessary. On board the A320, computers take care of all important issues. On monitors, the pilot gets instructions on what to do next. All inputs of the pilots are checked meticulously by a system for plausibility. For the first time, this aircraft is flown by a side stick, and inputs are checked by the computer before they are performed. Dangerous attitudes are excluded by the system. This was made possible by modern fly-by-wire technology. Because of this technology, the A320 has much less weight, which makes it more economical in operation. Bernhard Ziegler on the left is the spiritual father of the A320 and its system philosophy. An engineer and former test pilot, he is an impassioned promoter of automation.
You need this automatism. There is another type of automatism which is a must because we are not monkey. It's a repetitive business. Men hate repetitive business. Every flight to put the seatbelt on, seatbelt off, seatbelt on, seatbelt off. Every flight to do the same thing. Men are not done for that. They are bothered by this job. It's what we call the monkey business. Then you put an automatism to do that instead of the man. An automatism have no psychology. They are repetitive. They are just doing the job as they are instructed to do the job. And that's it. They have no problem with that. Men have problem with that.
Ziegler's philosophy is also the philosophy of Airbus industry, which is very successfully, as the sales figures show. As of today, more than 1,600 aircraft have been sold worldwide, but there have been setbacks. (1988). Air France Captain Michel Asselin passes the field of an airshow too low. When he realized the altitude mistake, the plane did not accelerate, nor did it climb as he commanded. 3 passengers seated above the center fuel tank died. Official cause of the accident, pilot's error. (1990), Bangalore, India. This A320 crashed and burned down short of the runway. 86 people died. Official cause, pilot's error. January 1992, Strasbourg, France. An A320 of Air Inter approaches the field 1,500 feet too low and crashed into a mountain. 87 people died. Accident cause, pilot's error. Warsaw, Poland, September 1993. This time it's a Lufthansa A320. The aircraft overshoots the runway and collides with an embankment. A passenger and a senior check captain died. At the time of the landing there was heavy rain. The crew was warned of wind shear on final approach. Therefore, they flew 20 knots faster than normally, a company procedure with Lufthansa. But the information given by Polish air traffic control was wrong, as proven by the examination of the flight data and the cockpit voice recorders. As a matter of fact, they had a strong tailwind instead of an advised crosswinds. 6 months later, the official Polish report states, cause of the accident were incorrect decisions and actions of the flight crew taken in a situation when the information about wind shear at approach to the runway was received. In other words, pilot's error. But this is not the ultimate truth. With the original data from the digital flight data recorder, we simulate the last minute in a computer animation.
200.
The pilots command the wind shear.
100. 50. 50. Retard. Retard.
Now they expect the spoilers to deflect. Nothing happens.
Jetzt damit. Vollbreaking. War es auf? Ja, voll.
Then they realize the embankment at the end of the runway.
Scheiße!
relatively speaking. In fact, we had so far, I cross my finger because it could happen tomorrow, but so far we had no accident which was directly related to a design deficiency or a problem on a system or structure or anything like that.
The Accident Analysis Commission of the German Cockpit Association are not satisfied with such statements. It took them 4 months to reinvestigate the crash. The pilots discovered discrepancies between the published report and their own operation manuals. Captain Christian Kapp was flying the A320 for years.
While working the accident, which Airbus also did, it became obvious quite early that the information given in the manuals in several places were inappropriate.
But these findings were presented in the report as though they would have been known before the accident.
Without giving any indication that these facts were only been gained after the accident, they could creep into this report. So one could believe the crew should have known this beforehand. But this wasn't possible, as this information was not common knowledge at the time.
The A320 computer needs several input signals to understand that the aircraft has landed. The radio altitude has to be less than 10 feet. When the strut of the gear is compressed, another circuit is closed. This signal is required by both main landing gears. Only then the computer deflects the ground spoilers and unlocks the thrust reversers. Because of the wrong wind condition advised by ATC, the aircraft lands in a low wing configuration. Only the right strut becomes compressed and switched. The left strut did not send any signal for 9 seconds. Therefore, the computer did not realize the landing condition and did not deploy the spoilers, nor did he unlock the reverse. The crew was unable to take appropriate action. The catastrophe was in the making.
Would you say that your colleague was still in command in this situation?
Well, from a technical viewpoint, he was not allowed to do anything else. There was no chance of manual interference, as the aircraft did not allow this.
This fact was reflected in the final report of the Polish Accident Commission. It also states for the manufacturer, the possibility should be analyzed to introduce the emergency use of ground spoilers and thrust reversers independently of meeting the criteria imposed by the aircraft logics. No Lufthansa pilot was aware which signals were required by the computer to understand that the aircraft is on the ground. 4 years after the first delivery of an A320 to Lufthansa, Airbus explained to the airline a bit more thoroughly how a landing was defined by the logics of their computers. Airline manufacturer found an agreement. Silently, Airbus delivered a better strut to all aircraft of the fleet. Lufthansa took care of the installation. Former chief of Lufthansa's Airbus fleet, Charlie Dorfmeister, explains how the new strut differs from the old gear.
I will show you an improvement made to our A320, 321 fleet. We have fitted all aircraft with new gear strut called a double oleo system. You see the new strut here. The difference with the old strut is that now the switch is triggered with a load of 2.5 tons, while the old one required 6.5 tons of load to initiate the switching. The switching is necessary in order to send a signal to all components that the aircraft is on the ground.
You have modified all aircraft in your fleet?
We fitted this new oleo to all gears of our aircraft of our 320 and 321 fleet.
He does not mention that this improved gear had been available a long time before the accident, as an extra for an extra price. Should only the load on the gear have been the accident reason?
We believe that the real cause was the false wind reading and the false weather report given to the crew. The pilots had been tracked. Conclusively, with any other aircraft, a similar situation would have developed. We are convinced that this is not specific to the A320.
Obviously, Lufthansa backs up the manufacturer. We confront the flight safety consultant Heino Caesar with this statement. Mr. Caesar was Lufthansa's safety pilot for more than 20 years and was involved in the early design phase of the A320 on behalf of the carrier.
When I think of conventional aircraft, or even the modern 737, 300, or 500, which Lufthansa also operates, this accident would have been much more unlikely, to say so mildly. At least would it not have been so severe because the pilots could have had the chance to deploy his spoilers manually. In addition, he might have realized that they did not deploy automatically and he could have reacted on the reverse earlier so that the lapse of time would not have proved to be so disastrous. Overall, I'm convinced that this accident was an accumulation of unfortunate events, but nevertheless is decisively related to the design philosophy of this aircraft.
In our Cologne office, we set up a meeting with the members of the Cockpit Association and the former safety pilot. We discussed the details of the Warsaw accident. We wonder why the pilot in Warsaw had no lever to pull in this critical situation to deploy the spoilers manually, like in any other aircraft.
I can give you a precise answer to that. It is because, in Airbus' opinion, the pilot is a necessary evil, an evil that already could technically be overcome, that is only tolerated given respect to the psychology of the passengers. A320 is an aircraft being constructed with precisely having in mind to eliminate the pilots. And by doing so, Airbus ignores the fact that for a given period of maybe 30 to 50 years, humans will be indispensable in the cockpit due to the imponderability in the programming these systems. But if human beings are still needed, the cockpit has to be designed as a tool for the pilot. This means deliberately dispensing with certain things that are technically possible in order to keep the cockpit easy to survey and operate. This borderline has been crossed by Airbus as they endeavor to establish themselves in a close market with an almighty American competitor by means of an extreme avant-garde.
The meetings with the pilots make it crystal clear. Lufthansa has introduced procedures that do not match with those of the manufacturer Airbus. For example, wind shear. Airbus uses quite a lower speed than Lufthansa, a contributing factor in the Warsaw accident. But beyond that, we find other divergences. Worldwide, V1 or Speed 1 is considered to be a critical mark during takeoff roll. V1 is a speed mark where the pilot must ultimately decide for or against the takeoff. Because an aborted takeoff is considered to contain an enormous risk, the V1 is always calculated in a manner that in case of an engine failure before V1, the remaining runway is sufficient to come to a safe stop. If the engine failure occurs at or after V1, the pilot has to take off and clear the threshold by 35 feet. That is a requirement by the authorities worldwide. For pilots, this phase is a high concentration time. After V1, there is no way to stop. History shows that even takeoffs aborted shortly before V1 have led to severe accidents. Therefore, Airbus has reduced its V1 to consider the reaction time of the pilots so the aircraft could be stopped safely on the remaining runway. A good idea. Unfortunately, Airbus keeps it as a secret. Lufthansa for some time now has been using its own procedure to reduce the risk of an overrun, regardless of the type of aircraft and certification. They too reduced the V1 in consideration of the reaction time of the pilot. Therefore, with modern Airbus aircraft, the V1 gets reduced twice. The consequence? An engine failure after Lufthansa V1, but before Airbus V1, will lead to a continued takeoff. That might lead to a situation where the aircraft will not clear the threshold by the required minimum altitude. Does Lufthansa not know about the Airbus V1 calculation?
I must confess, I really don't know. I have to check it.
Are there communication problems in sensitive technical areas? We asked the manufacturer in Toulouse.
No, but at the limit, I would say Lufthansa does not need to know.
It's a certification issue.
It's a certification issue. The difference is that on an A320, you have a 2-second margin, to make it short. It's not exactly that. You have a 2-second margin, which does not exist on the 737, on the DC-9, on the 747, and so forth.
That's my point. That's my point. That's only my point.
Yeah, yeah.
Okay.
And that is absolutely factual.
Okay.
Now, we have not made any kind of publicity to this additional margin to the crew because of we are safety-minded. We have always considered that V1 was a really critical limit. And for that reason, we have preferred to let the crew ignore that they have a little more margin.
2 times safety might be 1 time too much. It might become dangerous if procedures are used which are not compatible with modern technology, especially if the pilots are not informed.
How far should we dig into the details? It is said that pilots must not construct an aircraft. Correct. But we know about the danger of having someone in the cockpit as a push-buttonist. We have to know how the system works beyond the surface in order to understand such a complex system appropriately.
Likewise, in the new Airbus cockpits, like in the A340, the computer takes care for essential duties. Faults and errors are announced through the pilot-computer interface called the Electronic Centralized Aircraft Monitoring, or ECAM. Through this system, the pilots are advised as what to do. The Airbus A340 is supposed to be the most modern 4-engine jet in the world. Is this system safe and faultless?
This system is safe, for sure, but far from being faultless. There are things the programmer could not and did not think about. Sometimes we have to act against the instructions given on the screen in order to ensure the safety of the flight. Join us in the simulator. We are going to demonstrate this.
The A340 simulator of the Technical University of Berlin. We simulate 2 engine failures in normal cruise altitude. We ask the pilots to follow exactly the instructions given by the ECAM system. By doing so, a new critical situation arises. We document the scene on video and confront the Senior Vice President of Engineering at Airbus Industry with our findings. First, we simulate damage to engine number 1 on the left side. The pilots exactly follow the ECAM instructions.
Engine failure number 1. Yeah, start procedure. This is engine fault. Low N1 is confirmed. Thrust lever number 1. Confirmed.
The engine is shut down. Based upon the monitor indications, they have to believe that this engine has severe damage. The ECAM asks the pilots to push the fire switch on the overhead panel, which they do.
Agent 1, after 9 seconds. Stand by for time.
Shortly thereafter, the situation is under control. The flight continues with the remaining 3 engines on a lower level.
Ja, das ist ja voll abgeschlossen, ne? Aber das machen wir schon mal weiter. Das ist ja alles. Ja, wir fliegen jetzt so.
Now we set engine number 3 on fire. Again, the ECAM gives instructions how to manage the situation. And here specifically is the problem. By pushing the fire switch as instructed by the ECAM, the right-hand pressurization of the cabin is automatically cut off. The A340 has two independent pressurization systems, one left, one right. Because the pilots were asked at the engine number 1 damage to push the fire switch, the left-hand pressurization system has already been cut off. Consequently, both systems are now shut down. The cabin gets no more air conditioning. But the crew does not get any information about this new situation. The monitor does not give any warning, any advisory, or even a little hint of the arising problem. For the ECAM, the demonstration of the hydraulic system is more important than the loss of pressure in the cabin and that the air gets thin. It seems that the constructor does not yet understand the whole dimension of the problem. 4 minutes and 50 seconds after shutdown of the burning engine, the next problem comes up. The critical mark is reached. The oxygen warning triggered. Descent to 10,000 feet without time to ask the ATC, endangering other aircraft if they would be around. And this would not only be a simulation.
We are at the third failure. Yes. 2 engines plus the pressurization. It's not related.
It's related.
It's related?
It's related.
No,
We did nothing. There's no manipulation. We just followed it.
It's not true. It's not true. But I will cross-check. But it's not true. No. Let me ask somebody to.
Yeah, please.
Non, it's stupid. Non. Si maintenant on a un deuxième moteur en feu.
Ziegler asked one of his
La
engineers.
bleed aussi de ce moteur avec le coupe-feu. On a toujours les packs.
Bien sûr.
Qui sont alimentés sur les autres moteurs. Non, stupide.
But why is the simulator?
I don't know. Honestly, well, I don't know
The
if there
constructors
is.
look up their
I don't
manuals.
think, from my memory, I'm not flying sufficiently. I don't think there is anything which asks you in the ECAM to cut the pack. You see, the pack 1 and 2 are bleed by, but anyway, you still have one pack.
The peak is reached. Ziegler asks for a test pilot.
Rappelez-moi mon noyer. Rappelez-moi mon noyer. If engine damage. What is an engine damage? Is fire or no fire?
We as well cross-check the exact procedure with an Allen check
shows
captain
damage.
by mobile phone.
Is cut off. Yeah.
First doubts. The situation seems even.
Even if there is no fire warning, discharging 1 agent. That's procedure. Abnormal procedures. It's abnormal procedures. Engine 1, 2, 3, or 4 fail in flight.
No, it's a wrong interpretation of the procedure. That is not the point.
And then the checklist engine shutdown is red.
Ziegler expects the relieving phone call.
Okay.
Il faudrait que tu me vérifies ça dans les cams. À ce qui paraît qu'il y a écrit « If engine damage, push the fire button ».
Then corrections have to be made.
Alors, first, I confirm now, and I have a cross-check. First, if you have an engine fail, you do not have to push the fire button.
But it's it and abnormal procedures. Engine 1, 2, 3, or 4 fail in flight.
Yeah, okay. If the engine fail, you do not have to push the fire button. It is right that it is written, if engine damage, then you have to do that. Then you have to do that. This was done for a simple reason. If you have an engine burst, You may imagine that the fire detection could be destroyed, and in such a case, in this very specific case, nevertheless, you will push the fire button, although the firecock is not illuminated. It's not the case, because if you have an engine burst, blam, and a lot of other warning, a lot of things. Apparently, it's not the case.
And then the typical
Therefore,
Airbus standard
there was,
explanation.
In this case, a clear misinterpretation in the simulator of the crew of if engine damage. Damage is bursting, you have to check.
This is my
But damage means damage.
For me,
At the end, a totally different Bernhard Ziegler.
But let me put down a comment. It is a type of extremely low probability of event where you really need a crew to interpret. Because you cannot cover with the ECAM such low probability.
Ziegler's right, but this was never stated in public by Airbus industry until today. As well, it is right that this situation could not have been resolved only by the ACAM. That was understood even by Mr. Ziegler. So therefore, it's not man or machine, it's more likely man and machine.
If the machine is ill-defined or ill-constructed, it will regularly and repetitively make the same mistake. Human beings, on the other hand, are able to learn. Man realizes a potential dangerous action and will try to avoid or eliminate it in the future. Pilots can be conditioned and trained to cope with unusual and extreme situations, but a machine is not able to learn.
The Airbus is not an unsafe aircraft. But flying has not become safer with the introduction of automation. Accidents still happen. However, the accident scenario has changed. Now, we are facing more and more accidents where the system machine is not fully understood by the system man. Communication problems between manufacturer, airlines and pilots, imprecise manuals and less instead of more training are alarming causes of accidents. Nevertheless, Airbus insists on the almighty computers. They continue to work on even more sophisticated systems today. On June 30th, 1994, Airbus chief test pilot Nick Warner and another 6 people died in a crash on a test flight with an A330. The aircraft barely missed the front yard of Airbus industry. Probably Warner was not aware that he had no angle of attack known as alpha floor protection while the aircraft was operating in altitude acquisition mode. This detail only later was introduced into the aircraft manuals. Warner, like many other pilots,